Swift is one of the two original projects that became OpenStack. Swiftstack, it's software defined. It is OpenStack Swift at the core. We take OpenStack Swift and we repackage it just so we can differentiate it from you downloading Ubuntu's OpenStack Swift, but there's no code change, right? It's just a package name or an RPM name difference, so we can query a system database to see what's installed. So we let you build, operate, monitor, manage a distributed storage system, right? Span a single node, 100 nodes, 1,000 nodes if you want. Single data center, multiple data centers from a single pane, single management console. Can be done by a single sysadmin. A lot of the tasks that a normal sysadmin or a group of sysadmins has to do to manage Swift is taken care of by the controller. Swiftstack architecture, we are enterprise-grade product. We don't do hardware. We recommend hardware. We have opinions about hardware. Swiftstack is deployed in hundreds of companies. We have massive amounts of data stored behind our controller. Swiftstack is really three components. So storage nodes running OpenStack Swift and some Swiftstack monitoring and managing agents on top of those nodes. We are the Swiftstack controller, and Swiftstack also have a file system gateway. If you have legacy applications that only speak CIFS or NFS, spin up 1 or 2 or 3 gateways as ingest points into your cluster, and you can access your objects that way. Every little line that you probably can't see is what we provide, that if you download Swift yourself, you have to learn how it works, you have to learn how to manage it, and you have to manage it in a distributed scale. SNMP, Nagios, we do SNMP traps from all the nodes. We take the information into the controller can SNMP trap your current monitoring system. We've written custom Nagios check scripts that gets deployed on every node. So if you have a Nagios type monitoring system or anything else where you can execute remote checks, the code is there, right? It's all scripting, so you can open up the check things to see what are we querying on the system. We have role-based administration. You can give certain user auditor rights to your cluster, saying how much data did this account use last month. Do the kind of bill back, charge back features are provided. It consolidates data from every single node and presents it in a RESTful API or a web GUI. Capacity planning management. So we show you graphs. In the last 30 days, you put 14 petabytes into your cluster. If you continue doing that, you'll run out of space in 60 days from today. So management operations. We alert you if a drive goes bad. We can automatically rebalance the rings for you if a drive goes bad. If you check that checkbox and say, every time a drive goes bad, I don't want to be woken up at night. It's not an emergency to me. It's not a RAID 5. I have to get this replaced and rebuilt before I have serious data loss. We also do maintenance and support. So we alert you when there's new Swift versions available. We give you a big blue button to push to say, no downtime, roll this into my cluster. We do musical chairs intelligently across all the nodes. We update one node at a time. So without any lost connections, without any end user downtime, you deploy a new version of Swift with a single button push. And we also provide phone support 24/7. So a Swiftstack node, it is OpenStack Swift. We add all management components, authentication, monitoring agents, use package installers, and there's no single points of failure unless you go against best practice and deploy it on a single node. So our controller is a piece of software running on a different server somewhere, in a virtual environment, on a physical hardware. It doesn't matter to us. So there's a web-based controller. You have a RESTful API to manage it. It's designed to be on all the time. But in the case of a multi-region cluster, you only have a controller in one region. You don't need controllers everywhere because it's not in data path. Turn it off, your cluster will operate without interruption. So it is menu-driven. A lot of the functionality from the GUI can be done in scripting. Like instead of clicking the add user button on the GUI, you can do a RESTful API to the controller to add users, change passwords, request usage data versus going on a GUI saying, here's my dates, give me my data, do a RESTful API, you can script it all. The Swiftstack file system gateway, it is, for sake of argument, a Swift client. It's deployed on a Linux machine somewhere in the world. It doesn't have to be the same data center. It can be hosted in a public cloud if you want to. It can be hosted in a remote office as a local cache. It speaks CIFS or NFS on one way. You connect to it with a server or workstation. There's a caching partition that will accept writes like a normal NFS server. And then there's intelligence on the back end, of course, that syncs those files into objects in Swiftstack. We don't manipulate the objects like many gateway vendors will do. So if you write a file to our gateway, it gets synced into the cluster. You can come through the API later and download that object now through HTTP. If you upload something with HTTP into the Swiftstack cluster, you can go onto the gateway, do an LS, you see your object name, and you download it through NFS. If you create subfolders in NFS, those subfolders will be carried into Swift as a slash in an object name. So if NFS, I have subfolder / file, in Swift, it will look like the object name will now be subfolder / file name, will be the name of the object. The legacy of Swift, public cloud storage system, multi-tenant. Our controller is also multi-tenant. You can have many users and different roles inside of an organization. It's an authentication, chargeback, user management for the cluster. It is, once again, 100% software. If you build a virtual machine to deploy our controller, that works well. So if your controller goes down, easy to bring it up. You might not need a secondary one. If you deploy it on hardware, you can have it a standby controller, hot standby, waiting to, like Martin said, right? The one command saying, make me primary. Our controller is also based on open source projects, but there is proprietary IP in that controller, right? So without being a Swiftstack customer, you cannot use and operate. CEO and founder deployed Swift for Internap and Korea Telecom and some others. And he said, this is really, really hard. Even though I've done it a couple of times, there's very little things that can be reused. And it's a new deployment every single time. How can we make this into a product that works for the enterprise? So that's where we came from.